So what's the agenda going to be about? Well, I'm going to give a brief introduction on to Atmos International, the drivers of pipeline leak detection, the history of leak detection, looking at the internal and external technologies, the policies that have impacted leak detection and the development, the improvements that have been made to leak detection from an Atmos perspective, and then I'll have a summary slide of where we see the future of leak detection going. So firstly, I thought I'd introduce who Atmos International are. So we are a pipeline technology company, and we work in the pipeline industry, working with the oil, gas, chemical, water, aviation, and mining industries. And our primary two focuses are on leak and theft detection systems and simulation technology. We were founded in 1995, and Atmos has implemented successful solutions on thousands of pipelines in over 60 countries worldwide. We've been in business for over 25 years. We support more than 215 clients in 16 countries. We have a wide range of software and hardware products. We have a team now of over 180 dedicated professionals, and that's continuing to grow. And to date, we have our online systems installed in more than 1,500 pipelines worldwide. And we continuously invest a proportion of our profit in research and development. So why do we need pipeline leak detection? Well, pipelines are ingrained in our way of life and in our society, and pipelines are often used to transport commodities that are dangerous, valuable, or both. A little bit of history. That pipelines have been around for a very, very long time. There's early evidence to suggest that the Egyptians used them over 5,000 years ago to transport water. That was followed by the Chinese around 400 BC, where they actually used wax-coated bamboo pipelines to transport gas to their cities. But pipelines, as we know today, came about in around the 19th century. And today we currently have approximately 3.2 million kilometers pipeline worldwide. And they're everywhere. They're over land, they're in rivers, lakes, seas, and oceans. And pipelines suffer from leaks, spills, thefts, or ruptures over their lifespan. And you need some form of leak detection technology to mitigate that risk. You need to mitigate the risk for the environmental reasons, the risk of life, for the risk of reputation, and of course the economic costs of cleaning up these leaks. More recently, government policies and environmental pressure have increased, and this has meant that pipeline operators need to install some form of leak detection system. And as I said at the start of this slide, pipelines relied on by every nation, and the way of life that we're so used to today wouldn't be possible without the infrastructure of water pipelines, oil pipelines, and gas pipelines. So what are the causes of incidents? This is from a US study based on all the pipelines in the US, and they categorized the main causes of leaks or incidents that led to a leak. So you can have incorrect operations, you can have outside force damage, corrosion as the pipelines age, material weld and equipment failure, excavation, and you can have natural force damage such as earthquakes, etc. When the next study comes out, there's likely to be a proportion of that pie chart related to increased in theft. Worldwide, since the early 2000s, we've seen that pipeline theft has been on the increase, and this is causing more leaks to occur on pipelines as those tapping points fail. I thought I'd bring to the attention of what are the impacts of leaks, thefts, ruptures on pipelines. And I thought this was probably the most up-to-date news story that everyone was heard about. So at the start of 2019, there was a pipeline explosion in Mexico City. And this unfortunately cost the lives of 73 people, and 74 people were very injured. And it was classed as one of the worst pipeline disasters in Mexico's history. And this was caused by a theft event. So someone had tapped the line to start stealing fuel, and it went undetected because this pipeline section hadn't had any pipeline leak detection. This leak got bigger, and the vapors started to spread. And I believe, unfortunately, it was triggered by a cigarette being lit by somebody nearby. Those vapors ignited, and that's what happened. I thought I'd also give you a demonstration. These are pipeline thefts and they're on the increase worldwide. And I wanted to give you a demonstration of some of the different techniques used and the severity, as you can see in the top left, when a tapping point fails. These theft events you're looking at had actually been detected and located through Atmos technology. So the technology is available for pipeline detection, but how did they come about? Well, no continuous monitoring of pipeline was possible before programmable logic controllers and computers became available. So we didn't see any major change in terms of standard line walks, or you might have had helicopter flyovers, until around the 1970s, where we saw the first huge step in automated systems on pipelines. And this was started through the creation of the microcomputer. This slowly started to allow pipelines and pipeline operators to start to remote control and monitor certain aspects of the pipeline. They were able to start taking in pressure data, flow data, etc. The 1980s saw an even bigger advancement with the personal computer, and a lot of people say that this might have been the biggest single advancement in pipeline automation technology. So most leak detection systems didn't start their development until the late 70s. We started to see liquid and vapor sensing coming about, simple volume balance systems, RTTM systems, and the introduction of pigging into pipelines. We fast forward to the 1990s, we saw further developments in PLCs, we saw the development of remote terminal units, what we class as RTUs, and further SCADA advancements. If anyone's interested in what SCADA stands for, it stands for the Supervisory Control and Data Acquisition. And these developments were the first time that allowed pipeline companies and pipeline operators to collect and review historical data on their pipeline. The 2000s, as we moved to there, we saw further advancements in internet technology and hardware, which allowed even more remote control and automation. And between these developments in 1990 and 2000, leak detection systems improved significantly. And we saw even more technologies emerge. We saw the development of fiber optic cable, statistical analysis, and because of the internet and the advancements in computer speed and data storage, we saw the re-emergence of the negative pressure wave. So what solutions are primarily used today on pipelines? Well, I thought I'd like to show you a short animation. There's still the traditional helicopter flybys that fly over the route of the pipeline, monitoring any activity. We've seen the increased use of drones. There's always the tried and tested line walking, and some companies introduce sniffer dogs. We've got fiber optic cable that's now been laid along pipelines. We have monitoring of acoustic sensors, pressure sensors, and flow data inside the pipeline. And also more recently, we've seen advancements in smart ball technology, and of course, the use of intelligent pigs. So as I was saying, we can categorize the methods available to pipelines and pipeline operators into two categories, internal and external technologies. So external based LDS are obviously looking at the external characteristics of the pipeline. So you have line walks, helicopter flybys, fiber optic cable that can be laid underneath the pipeline if it's a liquid line, or above the pipeline if it's gas. You have vapor sensing tubes, liquid sensing tubes, acoustic sensors that are looking for the sounds generated by leaks. Vapor sensors and infrared cameras are often used on helicopters. Now, when we talk about internal-based leak detection systems, we're monitoring the characteristics inside that pipeline. So we have volume balance, we can monitor the pressure, we have real-time transient models, statistical analysis, negative pressure wave, and we also have pigging and smart ball technology. So what I want to do is sort of break down some of these technologies and give you a little bit of background into them. So as I was stating before, the most common method, and probably the one that's been around the longest, has been your traditional personnel walking the line and your flyovers. They're very reliable. They offer high sensitivity because you're walking the pipeline. You should be very easily to see a leak, and you're going to have high location accuracy because once you find the leak, you know exactly where it is. The downside of these methods is it's not continuous monitoring. If you have a large pipeline network, there could be delays over that. We have fiber optic cable, and this has been in development for over 30 years now. This runs alongside the pipeline or above the pipeline, depending on the product inside. It's very, very sensitive. It can pick up small leaks, and it's also very good in intrusion detection. So if you have a potential issue with theft, it's very good at detecting movement near your pipeline. It also offers high location accuracy. Some of the weaknesses of fiber optic cable are, however, it's quite difficult to retrofit to pre-existing pipelines because you have to dig quite close to the pipeline, which increases the risk of a leak. Thieves can cut the cable, and there is quite a high cost to install this type of technology. And we also have vapor sensing tubing. It works in a similar way. You have to lay cable, and it senses vapors created from a leak. We have liquid sensing cable, acoustic sensors, so they're used to obviously detect the hissing sound of a leak, and they can be very sensitive and high location accuracy. However, they do have some disadvantages that you have to have quite a lot of these sensors along your pipeline, and they have around an effective range of about 5 to 10 kilometers between sensors. Infrared cameras have obviously been used quite often, mounted on mobile vehicles or aircraft, or even used by hand. You know, they are highly sensitive and location accuracy is good, but they're not continuous monitoring. And also you have to have good access to your pipeline. And I did hear one story from one pipeline operator that for many years they were having these flyovers. And it wasn't until they did an intelligent pig run that they realized that the helicopters were actually flying over the wrong part of the pipeline. So there's risk with all technologies. As I was saying to you before, the computer revolution allowed a lot of internal-based methods to be developed, as we were able to remotely monitor pressure, flow, and temperature for the first time. We were able to store it, and we were able to historically review it. So we started to see simple flow balance system and rate of change systems being developed and integrated into SCADA systems. They can work for gas, liquid, and multi-phase pipelines. They're both very reliable types of systems, quite low false alarms, so operators trust when the system goes into alarm that there might be a potential leak, theft, or rupture on their pipeline. The sensitivity of these two methods is relatively low, though on rate of change this can be slightly improved in static conditions or shutting conditions when there's less noise in the pipeline. Robustness, they're both very, very good at that, but unfortunately they don't offer very good leak location accuracy. RTTM, this has been in development since the late 1970s, and it's probably classed as one of the most complex internal-based methods. It requires a lot of information from the pipeline in order to develop a model to monitor the pipeline. So you need temperature, density, pressure, flow, a lot of composition on the product types, such as density, viscosity, the diameter of the pipeline. So you build quite a sophisticated model that of course needs to be maintained. And this maintenance can be difficult. If a system can be maintained, however, you can get good sensitivity from it, around 1% or less. And it can offer fairly good leak location accuracy. Depending on the rate it's acquiring the data, you can get 1 kilometer or less, and it can provide an estimated leak size. Statistical analysis. This was developed in Shell, as Shell in the 1990s wanted to improve the leak detection options they had available. They weren't happy with the methods they were currently using, which was generally simple volume balance and rate of change in pressure. So the statistical analysis takes flow and pressure data and provides a volume balance system. But what's unique about it is it uses a probability ratio and corrected flows. And this probability ratio allows for high reliability, because when it starts to see the characteristics of a leak, it looks at to see if there's any operational activity that can maybe explain this change in flow and pressure. And if there isn't, then once it gets to around 99% certainty, it will go into an alarm. It can offer good sensitivity in gas lines, liquid lines, and multiphase lines, and it offers medium leak location accuracy. If you can provide a 1-second SCADA refresh rate, you can get plus or minus a kilometer. And this statistical analysis flow balance system is one of Atmos's main leak detection methods. It is actually the most commonly used leak detection system throughout the world. In the 1980s, the negative pressure wave principle was developed in the US. This system is an onset detection method. So when a leak, theft, or rupture occurs, it generates a negative pressure wave that propagates along the pipeline in both directions. And if you utilize pressure transmitters and RTUs to collect the data, you can provide a very accurate leak location. And you can detect very quickly, and it can detect very, very small leaks. Now, the problem was when this was first developed in the 1980s, the internet and the infrastructure just wasn't in place to deal with the high acquisition rate required. Generally speaking, most negative pressure-based systems collect at around 60 hertz. That's 60 samples a second. But as we saw and discussed in the 1990s and 2000s, that technology became available, and we're seeing quite a significant development in this negative pressure wave. More commonly, it's now used in theft detection. As we've seen probably in the last 10 years, we've seen this increase dramatically around the world, and this negative pressure wave solution is seen as a very good way of mitigating that risk. And of course, we've had pigging in the form of intelligent pigs. And we've also seen new technology, sort of smart balls. There was a study completed by the US Department of Transport called the DOT study. They did one in 2010 and again in 2012. And they reviewed all the different external and internal based methods. And they came to the conclusion that each leak detection method has its own advantages, but it also has its own disadvantages. And the best way to provide overall protection for a pipeline is to combine two independent methods. So what I mean by that is you could combine the negative pressure wave with an RTTM, or you could provide the negative pressure wave with a volume balance or a statistical analysis volume balance. That way, it mitigates the risk that, for example, let's say you lose the flow meters, you can still monitor the pressure. Or if you lose your pressure sensors, you can still monitor the flow. It also found in this DOT study that external-based methods are very, very good at finding leaks. And in the US, external-based methods were able to locate hundreds of leaks. So it's all about combining a mix of internal and external methods for the best solution. So I've just covered as best I can the sort of technology solutions available. I've talked about the computer revolution that saw huge changes in technology that has allowed a lot of these new software-based LDF methods to come about. But what are the policies driving leak detection at present? Well, in some countries, such as Germany, it's illegal to operate a pipeline without some form of leak detection. They also specify that you need that dual independent method, so two separate systems. In a lot of countries, however, it's still not a legal requirement, but a lot of pipeline operators see it as it's an important practice to do, and it's important for the pipeline safety. But as I said to you before, there's a lot of pressure growing. We've seen a lot of environmental movements over the last few years, and people don't want to see these major environmental disasters when a pipeline leaks. It's still the safest form of transport, these types of products, but leaks do happen, and we need to mitigate that risk. We need to be able to detect the smallest leak in the quickest time with the most accurate leak location. And we need these systems to be reliable, so when an alarm happens, the operators are confident to use them. The UK requires leak detection on pipelines as it's seen as good practice. And if a leak occurs, there's a huge investigation that happens. And if the pipeline operator is seen to have not done enough, the fines can be very large. And the environmental agency plays a key part driving leak detection systems. But I believe the biggest driver has been the American Petroleum Institute, or API. And these have provided a number of standards, and I've put the three main ones that are around today. So the API 1130, the API 1149, and the API 1175. And these are all around the internal based leak detection methods. So the API 1130 is a set of standards such as documentation, testing, etc., required to pick the best leak detection system for you. The API 1149 came around because it wanted to get pipeline operators to take into consideration how they operate the pipeline, where their pipeline is built and constructed, and the landscape around, because these factors can impact a leak detection system. So to pick an effective leak detection system, you need to look at your own pipeline, see what characteristics it adheres by, and then pick the solution that's best for you. The API 1175 came around, and this discusses the requirement that you need to look at leaks, thefts, and ruptures as three separate entities that can occur on your pipeline, and adhere technology to meet those needs. It also talks about that it's not good enough now just to have a leak detection system, that you need to constantly review and test that leak detection system. And more importantly, you need to go beyond your normal leak detection operation. You need to find where you can improve your system. And that's not just on the operators, that's on the vendors like Atmos. We need to keep looking at our technology and finding where we potentially have gaps in our technology and where we can further improve it. And even though the APIs are American standards, many countries around the world adopt these guidelines when they're selecting a leak detection method. And a lot of leak detection vendors have to prove that their leak detection systems adhere to the API 1130 and the API 1175 and API 1149. So what improvements to leak detection have been made by Atmos? Well, as I said, there's lots of challenges still facing leak detection. As environmental policies change, as the API standards change, we're starting to see that a lot of pipelines, especially aging pipelines, now require leak detection. But we start coming up against challenges. When these pipelines were constructed, leak detection might have not been thought about when the pipeline was constructed. So we often face challenges like lack of communication, lack of power, and lack of instrumentation, and we even have lack of housing for the equipment in the locations we need. As well as aging pipelines, we also need to constantly improve our leak detection performance in terms of sensitivity, response time, and leak location accuracy. So how do we do that? Because we need to mitigate against the ever-present risk of pipeline theft. So what technology have we done? As I said, flow balance is probably the most common used leak detection method, but its inherent, probably its biggest weakness was its leak location accuracy. If you could provide a very good SCADA refresh rate, your best leak location would probably be plus or minus 1 kilometer, which isn't ideal if you're trying to locate a very small leak. So what Atmos has done with our software packages, we've adopted hardware solutions into that. We can utilize our own data acquisition units, or we can get SCADA systems now to sample at higher rates. What that allows us to do is to collect data at a higher frequency, and has allowed us to improve our location from plus or minus a kilometer to plus or minus 100 meters, which means we've removed that inherent weakness. Here's an example. This was on a pipeline in Central America. So it's a single inlet and outlet. The section was 56 kilometers long, and it was pumping multi-product. And it suffers quite badly with pipeline thefts. We generally see around 2 pipeline thefts a day. So our system went into alarm, and we provided a location of 9.2 kilometers. And the theft event was actually detected at 9.21. If we weren't using our fast scanning module and we were just using the standard SCADA rate on this pipeline, we would have had an error of 2 kilometers. So by being able to collect this high frequency data, we've improved the leak location of this system from 4% to just 0.125% of the section length. That's a huge, significant improvement. The next challenge, as I said, is how do we get instrumentation onto pipelines where we need it or where the customer needs it? So we've developed what we call the Eclipse unit. And this is a non-intrusive solution that provides all the instrumentation we need to provide an effective leak detection system. It combines non-intrusive pressure, flow, and temperature, and it clamps onto the pipeline. We currently can work on diameters 4 to 30 inch. It's fully ATEX certified. We can bury it if we're concerned with tampering. It has all the onboard processing and communication solutions we need, and it can work on even painted lines. This has allowed us to now be able to provide solutions to very remote pipelines or to pipelines that just didn't have any infrastructure in place. Very briefly, this is 2 screenshots of intrusive pressure sensor matched with a non-intrusive. So if we just take the top left screenshot, the pink trend is non-intrusive pressure and the blue trend is intrusive pressure. And as you can see, they follow coupled, so we can get good levels of information and detail out of a non-intrusive pressure sensor. The dotted circle is actually showing a small operational change, and that's around 0.3 bar of change, which both sensors are effectively picking up. As well as the Eclipse, we've redesigned the expensive bespoke field cabinets to something far more small and compact, so that we can put these devices in very remote locations with the instrumentation we need. And we use these AWAS JSP units where we might not be able to install an Eclipse because the diameter might be too large or we don't have the space available. And all the communication options are available to us. So we can use radio link, 3G, 4G, and we can even connect to fiber optic if it's available. One of the other game changes we've done as well is trying to improve sensitivity when we talk about theft. Theft is very challenging because they're often stealing very small amounts and creating very small changes in pressure. And they often try to do this in dynamic or operational conditions to use the pipeline noise to mask their activity. So we developed what we call nanowave technology, which requires distributed sensors along the pipeline that we then cross-check, and using long filter lengths, we can detect very, very small theft events. And thefts, because they act very similar to weeps, we can use this technology to detect small weeps as well. So in the short time I've had today to talk, I've tried to give you a general overview of the sort of pipeline industry and how it's came about, the drivers of pipeline leak detection, and the improvements that have been made over the years. But where is the future of pipeline leak detection? Well, as I've tried to show you, no one pipeline application is the same, and as such, there's no simple off-the-shelf solution that all pipelines can go to. So the best approach to do is to combine different methods and technologies. So the best methods are combining a mix of internal and external options. And when we're going for internal-based leak detection systems, you should combine two separate methods. So that one might be utilizing the flow along your line and the other utilizing the pressure. And that will provide the best overall protection and dramatically reduce the risk of a leak, theft, or rupture on your pipeline. But what technologies are going to be available in the next 2, 5, 10, 15 years? Well, I think airborne technology such as drones are likely to continue to grow, and they might replace the traditional helicopter flybys. Software-based leak detection system is always going to be an important option, but we're likely to see that getting combined with more and more hardware solutions to improve sensitivity, robustness, leak location further. Satellite imagery might be an option. I'm sure we all saw the commercial launch of SpaceX and NASA recently, and SpaceX are launching more and more commercial satellites among other companies. And that means we will have access to far more imagery than we ever did at a more regular intervals. So that's something we could start looking into. Software solutions such as advancements of AI are also being looked into. And as cybersecurity and concerns for hacking become more prevalent, web-based secure applications are definitely going to become a more common feature. So thank you very much for listening. I hope you found it interesting, and hopefully I've got enough time to answer a few questions. But just before I answer a few questions, talking about innovation and constantly developing technology, I'm very proud to say that Atmos this year was awarded the Queen's Award for Innovation for our Atmos Wave technology. And our Atmos Wave LDS technology is based on the negative pressure wave principle. So as I've shown here, that Atmos is always looking at our technology and trying to find solutions for potential weaknesses in it and improve it further so that we can provide the best service to our customers. So thank you again for listening, and I'm more than happy to take any questions. And I've left my email on here as well. So if you prefer to email me a question, I'm more than happy to answer that way as well.
Hi there, Harry. It's Kate. I think that some people have left messages.
Yes, I've just got the. Yeah.
So.
I'm going to provide the list of slides to everyone. This is the question to Alistair, and I will provide all the sources, including the US Department of Study article for you. Actually, I think Will might have already dropped it in. He has. Yes, there is additional information on the Eclipse and Nanowave. If you would like to drop me an email, I can send out the data sheets for that. That's not a problem. Does anyone else have any questions they'd like to speak of now? Because I think we've answered them all in the chat.
Harry,
yes,
we've got one question about any policies from India, and I know that we have been working in India. So, is there anything you can share with that?
Yes, the Indian often adhere to most countries. They do quite follow the stringent API policies as well. So they might create their own, but a lot of them use the API standards as a benchmark and move forward through there. So yeah, Spencer's asked about gas lines. So the technology that I've talked about, both the internal methods such as statistical analysis, negative pressure wave, RTTMs, they all work on gas lines as well as liquid lines. You just have to have the right level of instrumentation. They can also work on multiphase and water lines. This presentation will be posted, and as I said, we will share a PDF of these slides so people can access the information. And as I said, my email's there, so if I don't get around to answering everyone's questions, please contact me and I'll be happy to share more information. Negative pressure wave on gas lines is dependent on the diameter and the length of pipeline, and it's also dependent on how packed the gas is. It can vary, but there has been some examples of the negative pressure wave working. But in that solution, if you did have a gas line, as I stated before, it's probably best to combine multiple methods, so having a flow balance with the negative pressure-based principle.
Just to check, Harry, did you answer the question about the latest vibration-based leak detection systems?
Yes. So,
Rakesh?
As I said, there is still a lot of research being done into vibration sensors and acoustic sensors, and some fiber optic companies often use acoustic sensors in their detection. The problem being with especially acoustic vibration with fiber optic is it's very difficult to test that it's going to be able to detect a leak. It's very good at intrusion detection and security purposes, but not a lot of pipeline operators are willing to spill fuel onto the ground to test the system. Acoustic sensors that you can clamp near the pipeline or onto the pipeline have shown to be very effective if you combine them with intrusive pressure sensors. But as I said in my talk, they don't have a very long effective range, at least from the research that Atmos has performed. We've generally noticed that acoustic sensors clamped onto the pipeline have a range of about 5 to 10 kilometers, and external noise can have an impact on them. But people are still looking into the technology. How about
leak questions there? Yeah.
How about leak detection in portable water network? Yeah, we can do leak detection in portable water network. As I said, we have to get a little bit more into the detail of that network. So we have to sort of look at the complexity, the diameters and the number of inlets and outlets, but I'm sure we'll be able to provide leak detection like that. When you sell a system, do you guarantee minimum size that the system is capable of? If you can provide a vendor with enough information on the pipeline, then yes, generally in our proposal, we will provide estimated performance figures based on our experience and your pipeline characteristics. Of course, we then recommend calibration leaks and real leak withdrawals to test the system.
A couple more there, Harry. From Paul Russell, are there restrictions when it comes to large diameter PE pipes with temp changes and wall thicknesses?
In regards to what, in terms of leak detection? The larger the diameter, obviously you're dealing with a far higher flow rate and higher pressure, so you might not always be able to get the same level of sensitivity you might on smaller diameter pipelines, but we can still provide leak detection system. Atmos has worked on diameter pipelines up to 52-inch, I believe, and we've worked as small as 2-inch. So our system, works, and we can take temperature changes in. So our software will, if you have temperature sensors available, will compensate for any temperature variation, etc.
And I think there's one last one. Can the LDS combine with NDT sensors to check leaks as well as health integrity? And that's from Nira.
So leak detection, generally speaking, would not generally be used for pipeline integrity. I mean, in terms when we talk about corrosion and wall thickness, etc., you generally, the best solution for that is intelligent pigs or inspecting the pipeline by. But I can't see, if you wanted to combine different methods, then yes. But leak detection, generally speaking, especially in Atmos, it's an advisory system. It's there to reduce the risks if and when a leak, rupture, or theft occurs on your pipeline.
A couple more, Harry, very popular this afternoon. Which methods best suitable for multiphase?
Yeah, multiphase is probably the most challenging area for any leak detection vendor, and Atmos is doing a lot of research into this. Generally speaking, our statistical based analysis, what we call Atmos pipe, has been used commonly on gas and condensate pipelines very effectively. But we are looking into the negative pressure wave solution as an option as well. But that does require, generally speaking, a number of pressure sensors spread along the pipeline. But Mohammed, if you're interested, please send me an email and we can discuss further. So apologies if this has already been asked, but can the system detect network leaks as well as, I can't read, detect network? Yes, if you have a large network, we can detect leaks on that. If you're asking that you have multiple inlets and outlets, yes, we're able to do that.
Okay, I think we can do the questions. They have your details on the presentation, which will actually be sent out to everybody, and they'll have your contact details.
Yes, they will.
So thank you to Harry, and thank you to Will for joining us. And
thank you for letting us come along and present. So thank you very much.
No worries at all. Like I said, the presentation will be sent out to those who registered and attended, and the video will be downloaded and put onto our website, YouTube channel, and on social media. So you can revisit it as many times as you wish. And then on the last note, just to let you guys know, to have a look at our website, which is pipeguild.com, for further webinars that are taking place. We've got our AGM, so if you're a member and want to know what's going on, you can join us on Thursday. There's still time to register for that. And then the onshore and utilities panel are doing their bi-weekly pub quiz. So you can test your knowledge by doing a quiz. So yeah, so thank you very much. Thanks for everybody who attended. And again, thank you to Harry and to Will.
Thank you very much. Thank you for everyone enjoying, and thank you for listening. Thank you.
Thank you.
Thanks, guys.